In this video, we are going to be looking at how to calculate the Ka of a weak acid given concentration and pH. To calculate the Ka of a weak acid solution, we have to use the initial concentration given and the pH value for the weak acid. To solve, we will use the layout for weak acid calculations, and this will be using the generic equation, ice table, and equilibrium constant expression. We first write out the equation, plug in the initial values in the ice table, and solve for the equilibrium concentration of H plus using the pH to fill out the rest of the ice table. Once the ice table is filled out, there will be no missing variables. We will then plug all equilibrium values into the equilibrium constant expression and solve for Ka. For our example, we have calculate the Ka value for a 0.175 molar solution of a weak acid HA with a pH of 4.27. For our steps, we're going to use our weak acid equation, an ice table, and then we're going to find the concentration of H plus at equilibrium with the pH. We're going to find X in the ice table. And once we fill out all values in the ice table, we're going to use those equilibrium values to calculate Ka. We have not been given a specific compound for our weak acid, so we're using the generic equation HA. For a weak acid, it's going to donate a proton, so we're going to have H plus and then A minus. All acids and bases are aqueous unless they are insoluble solids, so we have AQ. For our ice table, we have an initial value for the weak acid, 0.175. We are given a pH value of 4.27. The pH value does not correspond to an initial concentration of H+. Instead, it's always going to be an equilibrium value of H+, because the weak acid stabilizes and then the pH meter is used to record the value of the pH of the solution. To find the equilibrium concentration of H+, we're going to do 10 to the negative pH equals the concentration of H+ at equilibrium. 10 to the negative 4.27 equals 5.37 times 10 to the negative fifth. We're going to plug this in for our equilibrium value of H+, and we have an initial value of 0 for H plus and A minus because we are not mixing any solutions together, or we do not have an initial concentration for either given. The pH value is always for the equilibrium concentration of H plus. For the change column, since we have an initial concentration of weak acid, we're going to subtract X from the reactant side and add X to the product side. To be able to fill out the whole ice table, we have to find the X value. Since we have I, C, and E for H+, we can solve for the X value by having 0 plus X equals 5.37 times 10 to the negative fifth. We can perform this calculation because I plus C equals E for any ice table. This brings us to a value of 5.37 times 10 to the negative fifth for our X value. Now we can fill out the rest of the ice table. For A minus, we have a value of 5.37 times 10 to the negative fifth, and for HA, we have a value of 0.1749. Even though I'm putting down a value that is rounded for HA, I'm still going to use the full value in the calculator and for all other calculations that I do in chemistry. I will never use a rounded value before the end answer in any chemistry problem. Before we plug in the equilibrium values into our Ka expression, we can write the Ka expression without the values, we'll have Ka equals the concentration of H plus times A minus divided by HA. We can now plug in all equilibrium values into our Ka expression. We have Ka equals 5.37 times 10 to the negative fifth squared divided by 0.1749. This gives us a Ka value of 1.65 times 10 to the negative eighth.